Hello, friends. I hope you all are well and good. First of all, I want to thank all the viewers for their extremely good response with regard to previous lecture about the module of basic econometrics. In this lecture, we will discuss about the basic or necessary assumptions for the estimation, and along with that, we will discuss about the different types of data for econometric analysis. So let's start with basic or necessary assumptions for estimation of an econometric model. There are various types of assumptions with regard to the estimation. Some of them are the mean or expected value of our error term, it should be equal to 0. If we take the expectation of our error term, then it should be equal to 0 for all the items that we have included in our econometric model. And if this assumption violates, then we may face the problem of biased intercept. The second assumption with regard to the estimation is the assumptions of homoscedasticity. It states that the variance of our error term, it should be constant or sigma square for all the items that we have included in our econometric model. If this assumption violates, then it may lead the problem of heteroscedasticity. And the problem of heteroscedasticity arises basically when we are dealing with cross-sectional data. The third assumption with regard to estimation is serial independence or non-autocorrelation. It states that the covariance between two error term, it should be equal to 0 for the two error term should not be equal for each other. If this assumption violates, then it leads to the econometric problem of autocorrelation. And the problem of autocorrelation basically arises when we are dealing with time series data. The fourth assumption with regard to the estimation of econometric model is that our error term should be normally distributed. Basically, it required when we are going to run the different parametric as well as non-parametric test in our econometric model, then the error term should be normally distributed or bell-shaped. The fifth assumption with regard to the estimation of econometric model that there should be zero covariance between the error term or the residual and the explanatory variable. Here, the error term is identified as epsilon I and explanatory or independent variable is identified as xi. So the next are the different types of data for econometric analysis. When we are dealing with data and their analysis, there are different types of data that may be cross-sectional, time series, panel data, experimental or non-experimental data. The cross-sectional data, basically it is also known as microeconometric data. So if we are dealing with cross-sectional data, it means there may be different entities, but there may be only single time period. For example, if we are dealing with the sample of individual households, firms, region or countries. For example, if we are going to, you know, going to analyze the comparison of GDP for different countries for a year of 2020, then it may known as the cross-sectional data. Or if we want to analyze the comparison of different auto sector industries for only one financial year, for example 2020, then it may called as cross-sectional data. But in time series data, for time series data, it may be single entity but different time periods. The best example of a time series data is the GDP, data with regard to GDP, money supply, export imports, exchange rates, stock exchange, that is mostly volatile in nature. And for example, if we want to analyze the data on exports, Indian exports, for different time periods, for example, we are going to analyze a data from 2000 to 2020, then it may known as time series data. The third one is panel or longitudinal data. It is a combined section of a cross-sectional as well as time series data. If we are dealing with the different multiple entities for more than one time period, then we may formulate that we are going to analyze a panel data. And another form of data for econometric analysis, it may be experimental or non-experimental. As we know that experimental data mostly are the results of our laboratory experiments, and mostly it is used in natural sciences. But of course, when we are dealing with social sciences, it is hardly to use experimental data. But some cases we may use the experimental data through the control or non-controlled experiments. And mostly in social sciences, we deals with the non-experimental data for our analysis. That may be collected through the surveys, through the interviews, and further be analyzes by the appropriate statistical softwares. So it is enough for today. In next lecture, we will discuss about the single linear regression model and how to formulate, how to estimate, what are the basic steps of estimation, specification, estimation, and that's all about with regard to the single linear regression model we will discuss in our subsequent lectures. So thank you very much. I hope you will enjoy it. And at last, I want to thank you very much for all the listeners.